Hello everyone and welcome back to the e-learning. In the previous sections you would have learned how to use the basics of the app designer, so learning how to navigate between pages and how to incorporate an API that was designed in the API designer and how to actually pull that data in to the app designer and into your application to then be displayed within a table within the actual page itself. Beyond that, we then went ahead and built App 1, which allows us to collect and store information about our equipment. So using a few simple forms, some input fields, some date pickers and a slider, as well as the ability to upload an attachment, we now have a full first application which allows us to collect that data and store it in the equipment database. Before we move on to build the second application, we're going to build a server script. Now, a server script is essentially just a microservice. So it's a little package of logic that can be triggered at any point, at any time, from basically anywhere within the platform. And you can do this by running the script itself or by setting up an API to call the script and trigger it and then return a response. So it's really easy to trigger these scripts from within your applications because you can just use an API to call the script. Now, server scripts within the platform are really powerful. So let's set one up now with its primary focus to adjust the data within the equipment table. When we enter a new piece of equipment, we select the initial checkup date and then we select the checkup interval on the slider. Now, these two properties allow us to calculate how many days are left until we need to check up on the piece of equipment next. And we can do that with a server script. And if we run it, it will automatically check every item in the equipment database. It will compare the initial checkup date with the checkup interval, and it will calculate how many days are left until that piece of equipment needs checking. So let's get that set up now. Let's search for the script editor. If we open it, it will open in a brand new tab. Let's just have a quick overview of how the script editor works. So it's split into three sections. On the left are your resources. This panel here will contain all of the scripts when you have a project that's open. And then this section is where you'll actually write the code which goes in each of the scripts. But let's come all the way back here to the left and have a look at the resources. Now, these resources are everything that's available within the platform. So under API, we'll see that we have both the APIs that we've generated for both of our tables. We have our API equipment with its 4 CRUD methods, allowing us to interact with the table, and the same thing for our inspections API. We can also see our table resources here. So these are the 2 tables that we have within our platform as well, the equipment table and the inspections table. We'll come back and look at global scripts later in the course, but let's have a look at modules for now. Now, modules here are referring to NPM modules, which are essentially just packages or libraries of code which you can utilize for a number of different functions. There are millions of NPM packages available, and by default, the platform comes with some internal modules already built in. So if we click the drop down here, we can see we have a load of JavaScript modules, and one of the ones that we will be using in the script shortly is the moment module. You may have noticed as well, there's a custom parent here, and that's because Neptune allows you to search for and to install NPM modules straight into the platform to be utilized within server scripts here. Also within the app editor if you're doing any custom pro code stuff. Now, before we get stuck in and actually create the first script, I just want to show you how to work with these modules, how to actually install them. So let's jump back to the cockpit and we can search for npm. Now this brings up the npm tool, which allows us to install and to update any node package modules that we have within our platform. And by default, we don't have any custom modules installed. So let's add one. Here we can search for the actual module within the npm repository. So we can search here for as an example for the moment module, which is obviously already installed, but we can install it as well as a custom module if we'd like to. So here we can see a list of all the npm modules that match my search criteria, and I can click on the title of any of these to open the module within the npmjs.com website. This is great because you can see all the documentation, the change logs, the number of downloads, the current version, and all the information you could ever really need and how to use it available via this link. But let's close that down for now. And to install it, all we need to do is click on the module. Now, initially, you'll get this message saying, please set a custom npm installation directory. And that's because these modules, when they're installed into the platform, they need a folder to live in. So we can set that up within the customizing tool. Here we can see the custom settings for our system. And under the general tab, we can see we have a path for our npm installation. So let's go into edit. We'll do a // to point to our local directory. And then you can give the folder whatever name you'd like. Just ensure that you have actually created this folder within your directory as well, where your Planet 9 instance is running. Now, we can hit save, and we'll go back to the npm tool. We'll hit add. We'll search for moment. And if you're still getting this error message, then all you need to do is restart your instance, which should only take a few seconds. So let's go to system settings. And here in the top right, we can hit restart. And this will automatically restart the instance for us. And then we should be able to jump straight back into our npm tool after a refresh. And we should now be able to add the moment library. So yes, here we go. Now we can select a version. And we can see we've successfully installed the moment library into our platform. So here we can see the path, the version, and if we put it in display mode, and we close out of it, now we can see that moment library installed within our npm modules. Great. So now, if we jump back to the script editor, and under the project dropdown, we refresh the master data, which will basically open the script editor as if you've just hit refresh on your browser. It will pull in all the latest information. If we hit the drop down on modules, we should now see we've got a custom module called moment. So this is great. It's exactly the same module here as the one built into the platform, but you can choose a different version with the custom one if you wish. But let's just collapse that down for now and let's get our script set up. So we're going to create a new project. So to do that, we hit the drop down on project and we hit create. Let's give it a name. And we'll assign it to our eLearning package. Now, once you create the project, you'll see it's visible here within the second panel. If you right click on scripts, you can add a new one or you can import an existing script. For now, let's create a new one and we'll call it calculate days until check. And that's the property within the table that we're going to automatically calculate using this script. So let's press add, and now we'll see we've got a brand new script within our scripts parent here, And if I put it in display mode, you can see it's just a JavaScript script ready here to be used. And we can't type in it unless you right click and go into edit mode. Then we can type in the script here within the script editor itself. Now, this script is going to use the moment library and it's going to interact with the equipment table. So now let's go to our resources and let's drag and drop those resources that we need in this that the script's going to be interacting with into the script. So modules, let's use our custom moment module and drag and drop that onto our script. We can give it a new contextual name, but in this case, let's just leave it as moment. And now we can see this script has a module inside it called moment. Let's do the same thing for our equipment table. We'll just drag and drop it onto the script. And now we can see our script contains both a table and a module. And we can see all the properties of our equipment table here as well. Now, what's the advantage of doing this? Basically, any resource that you have assigned to your script will automatically create all the code snippets that you could need in order to interact with the resource. So, for example, if we right-click here, we go into code snippets, we can see we have a selection of predefined code snippets ready to be used. Under entities, and then let's go with a basic and a find. If we hit equipment here, we'll be able to see this code snippet generated automatically, which will find data within our equipment table. We can just copy and paste that in. There's loads of comments in these code snippets as well, which allow you to understand how to use it. But for now, we can just take out all of this. We'll leave it with just a very empty table.find method. And we should be able to do a console.log of that data constant being defined here. At the end of every script, you should put a complete statement so it knows it's finished as well. Now, we should be able to run this. So right click and run. And here we can see that it's pulled in the one record that we have within an array. We can see the object being our one record straight from our table. So earlier we added in a power supply with a part number here, with a test latitude and longitude. And we can see all the other properties here are null. Now this days until check is the one that will be automatically calculating with this script. So just remember that. So that's how to use a code snippet to really quickly and easily interact with your resources. There's loads of snippets here for creating, deleting, merging. You can come into advanced as well, where you can do more advanced selects, for example, using a type ORM syntax. But for now, we can just collapse this all down, and then let's close the code snippet, and we'll just clear our script for now. So now I've just copied and pasted in a comment, which will allow us to understand what this script is going to do. So for each piece of equipment, we're going to get the checkUpDate property and add the checkup interval to it. And this will give the date that the equipment needs to be checked on next. We're going to then compare this date with the current date, which will generate the days until check variable. And then we're going to update each piece of equipment with this variable. So let's write out this script now. There's a few really important parts that we can learn as we go along here, but we don't have to write this whole script from scratch in order to make it work. So the first thing we're going to do, import moment. Now we've already dragged and dropped our moment resource onto our script. So all we need to do to import it, declare a variable, we'll call it moment. And all we need to do is modules dot and then the name of the module, the contextual name that we set when we dragged and dropped this onto the script. So in this case, it's just modules.moment. Right. Now we're going to use moment to get the current day. The way that we do that is we declare a variable. Then we're going to use the moment library to get the current date in the right format that we'd like. So there we have it. This will now use the moment library to generate a new date. That's going to follow the year, month, date, or day format. Now, at any point, you can use a console.log statement to see the information that you're working with. So for example, we can console log the current date, and if we run this script now, we can see that it's printed the current date and time. There's one other way of logging information within server scripts. You can use a log dot and then either info, warning, or error. Now generally, you'll probably want to use log.info, and here, let's log the same variable, and we'll see what happens. We run the script now, see we still get our console.log, but the log.info is sending the data somewhere else. So let's jump back into the cockpit, and we'll search for log. Here we can see system logs. Within the system logs, you can see any logs from the actual system itself, as well as any logs being made by the server scripts. So all we need to do is visit today's date, and here we can see we have one new log created a few moments ago, and there's the message, which is the current date and time, which is great. Cool. So let's close that down. We can comment these two lines out. A top tip here, if you press F1, then you can bring up the command palette, and then here you can add line comments, and you can comment a number of lines at one time. But let's carry on for now. So next, we're going to get all the records from our equipment database. So let's actually use one of the code snippets to do this. We'll right click, go to code snippets, go to entities, advanced, select equipment. And that's already what we're showing here from last time in the code snippets. And we're just going to copy and paste this second part into our script. Now, all we need to do here is we just need to understand that it's going to put the data in this constant called entity, which we can actually rename to table. And now all we need to do is get rid of this where clause. We don't need it. And we're just going to use the .getMany. And now this here is, as I mentioned earlier, the type ORM syntax. You can learn more about typeorm at typeorm.io. And here you can see all the documentation and loads of examples of how to work with this specific syntax. It's very powerful for essentially creating SQL statements, but with a much more user-friendly syntax. But you don't need to learn all of this from off by heart, because the code snippets are using typeorm already. So all you need to do is learn which code snippets you need to use when and where. So now we've got all our equipment data within this constant called equipment table. We might as well do a console log just to see what that looks like. Should just look like our one record. Yep, there we go, brilliant. And so now we can do our logic. What we're going to do is we're going to loop over each record in the database, and then we're going to perform that check. Now, rather than writing all of this from scratch, I'm going to use a loop that I've prepared earlier. Here we go. Now let's just understand what this is doing. this is going to, first of all, console log a line, and then it's going to create two variables, one called the check update, which is going to be the equipment table with the position I. And if you're familiar with a for loop, you'll know that every time that this loop iterates, it's going to increase from I being 0 to 1, and then 2, and then 3. So this is how you can loop over a number of entries. The for loop is actually set to be the length of the equipment table. So it's only ever going to loop for the number of entries within the table. So the check update is always going to be whatever position in the loop we are, referencing the equipment table constant and looking at the check update property. And then this is wrapped in a moment function, which is going to format it into this correct year, month, day format. We're also going to grab the checkup interval, but we're not going to format that with moment. We're just going to grab that from the current position in the loop and reference the checkup interval. So now we can see that we're going to log those two as well, just so we have clarity over what information we're storing in these variables. Next, we're going to create another new variable called date of the next check. And this is going to be, again, utilizing the moment library to pull in the checkup date. And we're going to add the checkup interval to it. And we're going to say that the checkup interval is in days. So we're going to add this many days to our checkup date. And then we're going to log that as well. And then all we're going to do is create one final variable called days left. And we're going to use the built-in math function to round the duration of the difference of the current date and the date of the next check. And we're going to format that as days. Now this might be quite a confusing statement if you're not familiar with the moment library and you're not super familiar with JavaScript, but this whole script will be provided for your use in the e-learning here. So it's good to understand, but you don't need to know exactly how to write this from scratch if you don't need to. We're going to log that variable as well. And then the final thing we're going to do in this loop, so at the end of looking at our record, we're going to update this information based on the part number, which is our current position in the for loop, dot part number, and then we're going to update the days until check with our days left variable. So now this script is completely ready to go. Cool, so now we can run the script and we can see that we've initially printed the table. And then we've started our for loop because we can see our lines printed here. The first variable is the checkup date specified here. So the 28th of the 5th, you can see it matches up. This is the checkup interval being number 10. And then this date here is the date of the check. So when the check is due. And in this case, it will just be the 28th of the 5th plus 10 days, which is the 7th of the 6th. And then comparing this checkup date with today's date, which is the 15th, you can see that we are 8 days overdue, so it's going to deliver a -8. Now, if we run this script one more time, you'll see that the initial print of the table already contains that days until check -8. And that's because the final part of that for loop was to update the table with that information. So now we can even go back into the cockpit, open up the table browser, jump into our equipment table, select everything and hit run. And then here we can see our power supply with the days until check being -8. Brilliant. So now the script is all set up. We're going to utilize it within app 2. It'll be one of the first things that we do, As soon as we set up the app, we're going to set up an API, which will trigger this server script. So then when the app is loaded, the current date and time of the system will recalculate how many days left each piece of equipment has until it needs to be checked. And then once this script is complete, it will then pull that updated information into the app to display to the user. Before we get started with building app 2, there's a few additional points I'd like to mention when it comes to the script editor within the Open Edition. First of all, when is it appropriate to use a server script? Well, essentially, whenever you need to abstract your interface from the backend, a server script is the perfect middleman to do such a job. So instead of your app directly interacting with a database, for example, instead your app can interact with a server script, which then interacts with the database. And this allows you to have complete control over the read and write access to the database. You can add additional validation to your server script, for example, and you can simply accept data in from your app to the server script and then pass data back from the server script to the app once it's finished interacting with the table. This is also useful for when you need to perform a process-intensive task, such as reading or writing a lot of data, and you don't want to block the user interface whilst this process is completed. You can trigger a server script which will run it on the server in the background instead of running it directly from your application. It's worth noting that there is documentation for the script editor, which gives you lots more details on how to use it. And of course, there's documentation for all the tools across the platform. Feel free to check them out. It's all available here within the community. But there's one particular point here under the keywords chapter, which is really useful to know. There's a handful of variables within the script editor which are essentially reserved. They have a unique purpose and should only be used for that purpose. So let's have a look at them now. First of all is the rec keyword. So let's just start with a new test script, which we can use just to understand these keywords. So if we right click and we go into code snippets, we can search for rec, and that brings up the request code snippet. Let's copy and paste that in. We can see that this is used when there is a request object when the server script is used as an API endpoint. So all this means is when you call the server script via an API, you can pass data into the script, and you can get that data from the request body using this rec.body statement, and that puts all the data into this constant called data. And this is really useful because by default it will always pass all the data of the user who's made the API call. So you can always check who's made this call and then perform certain logic depending on whether it's an administrator or another user role that doesn't have particular access to a table. The next keyword is result. And result is essentially the opposite of request. It's for handling data that you need to return out of the script. So you need to pass out of it. So if we cancel that search, we'll come in here to the result, and we can see that there's two different snippets here. There's a description snippet, which tells you how to use it, and there's an actual snippet itself. But ultimately, it's just the word result. Whatever you set as result will be the output of the script. So here you can return a success or failure message depending on the logic of your script, for an example. So the next keyword is operators. And operators are used within queries. And we can see that here within the code snippets. If we come to entities and then operators, you can see here that we have any, between, equal, more than, not, and all of these operators are stored under the operators keyword. And this is possible to see if we perform a console log of operators. So here, if we console.log operators, you can see all the operators assigned within that keyword. The final keyword to account for is WF data. Now we'll come back to look at this in the next section of the e-learning, but essentially all you need to know for now is that the WF data keyword is used for when you're handling workflow data. So when you have a script as part of your workflow, you can handle the data coming in from the workflow and the data that should be passed on to the next step of the workflow using this WF data keyword.